Hello students, and we are still on graphs of linear functions, and we're going to look at linear functions today. So a linear function is expressed as f of x is equals to mx plus c. So this is the general form of a linear function, which means it's a graph of a straight line. Linear means straight line. So m in this case, it represents the gradient of the line. The gradient, it means the steepness of a line. If you could look at this graph, m will represent the gradient, the steepness of the slope. And in order to find the gradient, you take 2 points on the line. You take the first point and you take the next point. So gradient is measured in relation to the progression of the x-axis, and the y-axis is going this direction. So you take your first point, lower point, and you take your upper point. Then you say that b upper point minus c lower point. That's how you find the gradient of the slope. So you would find the change in b, the change in b, and the change in y, the change in y and the change in x, and then you can plug in the coordinates of the individual points so that you can find m. And c in the equation, it represents the y-intercept. This is where the line graph meets with the y-axis. That is represented by c in the equation. So if you are given 2 points and you are asked to find the equation of the line, you will first find m, the value of m. When you have found the value of m, you take either of the points, then you put them into this equation. Then you solve this equation, you would have found your m. After simplifying this equation, you come up with the equation of a line. So let's do an example. If you are given, find the equation of a line passing through point 23 and point 67. So first of all, we find m, the gradient of the line. So m is given by change in the y over change in the x. So we start with change in the y, which is 7. So this is the y, this is the x, this is the y, this is the x. So this is y2, y1, x2, x1. So we plug in into this formula, y1, 7 minus 3, x2, 6, and x1 minus 2. So we are doing this in order to find m, which is equals to 7 minus 3, that's 4. So we put a 4 here. 6 minus 2, that's 4. So our gradient is 1. It's 1. After we find out that our gradient is 1, we are going to take either of the points here. Either of the points work. So we can take this one and we put our y, the formula, minus y1 is equals to mx minus x1. So we put either of the points. I'm going to go with this one. So this is y minus y1, which is 3, is equals to m. M is 1. Then we are going to put our x minus x1, which is 2 here. So our x1 is 2. So here we say y, which remains, we want to put it in this form. We want to put it in this form. So I want to write it on top here so that you can see. So we have y minus 3. We have plugged in our points is equals to 1. X minus 2. We have plugged in our points into this equation. So here you are going to have y is equals to 3. Y is equals to 3 plus x minus 2. So we are going to have y is equals to 3 plus x minus 2. 1 multiply this whole bracket. Then 3 moves from here to here, it becomes plus 3. So we are going to have plus 3 minus 2, that's going to be 1. So y is equals to x plus 1. This is going to be the equation of the line. So we'll move on. We'll still be on linear function. In the next video, we're going to talk more about the y-intercept and the x